So we've seen in previous sections that maths can be used to solve a variety of practical problems, and trigonometry is one of those types of maths. Today we're going to use trigonometry to help us solve the problem of how to chop down this tree. Now, we could just chop down the tree and see what happens, but there is this rather lovely building next to it. If the tree happens to be too tall, then it could end up causing a lot of damage if it hits the building. We could try measuring the height of the tree by dropping a tape measure down from the top, but it looks a little bit awkward to climb. Trigonometry is going to offer us an easier way of solving this problem. So first of all, what we need to do is imagine that we have a triangle where one of the sides is the tree and one of the other sides is the ground. So clearly we're going to have a right angle here, which means, if you remember from your lesson on Pythagoras, that this side opposite it is the hypotenuse. Now, for trigonometry we also need to be able to explicitly define the other two sides, and we're going to put them in the context of the angle that we're trying to measure, which will be that one on the ground. If we look first of all at this side here, which is opposite the angle, quite simply we call that the opposite side. The side on the ground then, which is next to the angle, we call the adjacent side. Obviously the hypotenuse is also next to the angle, so we could call that the adjacent, but as it has its own special name already, we'll leave it as the hypotenuse. So now that we've got ways of identifying these two extra sides, we can start trying to take some measurements. So the two things that we can measure are the length along the ground and the angle on the ground as well. So let's have a go at doing that now. So first of all, we measure the angle on the ground. We can take either a tape measure, or I'm going to use a trundle wheel here, and we can measure a distance, 1 meter, 2, 3 meters, and we'll stop at 4 meters. So then from that point we want to see what the angle is to the top of the tree, and we'll use a clinometer for that and find that the angle is 60 degrees. With these two measurements, we can then use something that we call the tan function to work out the final side that we want, the opposite side. So let's go back to the classroom and give that a go. So let's take those measurements that we made outside and put them into a diagram. Now, our diagrams don't have to be accurately drawn, but it is important for them to be neat. So I'm using a ruler when I go about drawing this triangle. Now that we've done that, let's mark on what we know. First of all, we have the right angle. Then we measured this 60 degrees, which was from the ground to the top of the tree. And finally, we measured 4 meters from the base of the tree to the building. Now, we talked about using the tangent function, and on your calculator there is a button marked tan, which is short for tangent. When we use the tangent function on our measured angle, the resulting value that it gives us is the same value that we would get by dividing the opposite side by the adjacent side. So let's say that again as a formula. If we find the tangent of an angle theta in a right angle triangle, the value we get is equal to the opposite side divided by the adjacent side. Notice that in the formula we've abbreviated tangent, opposite and adjacent to 3 letters. This is the form you'll commonly see them written in. Here, that means that tan 60 is equal to our unknown value x, which is our opposite side, and it's divided by our adjacent 4 meters. Now we have an equation that we can work with to find x. First, we need to get x on its own. So we've currently got x divided by 4. So if we multiply both sides by 4, that will give us 4 times tan 60 on the left-hand side, and x left on its own on the right-hand side. Now we can type tan 60 into our calculator, and that will give us approximately 1.732. So we have 4 times 1.732 is equal to x. Now, leave that 1.732 in your calculator so that we don't end up with any rounding errors, and multiply it by 4. And that will give you 6.928, which will be the height of our tree in meters. And as the tree is 4 meters from the building, it's a good thing that we didn't chop it down. We could have ended up with some smashed windows. In the next lessons on trigonometry, we will go through some more examples and also introduce the sine and cosine functions.